Hey guys, in this video we are going to discuss about quantum physics and we'll mainly focus on photons, the energy of a photon, and we'll solve some problems involving the rule for the energy of a photon. So before we go there, let's start with our basic understanding of the electromagnetic spectrum. So the electromagnetic spectrum looks like this. It goes from radio waves to gamma waves or gamma rays. In terms of wavelength, radio waves have the longest wavelength, the gamma rays have the shortest wavelength. In terms of frequency, it is inverse. Higher frequency will have a shorter wavelength and a lower frequency will have a longer wavelength. So, the relation between frequency and wavelength is C equals to F lambda. So, speed equals to frequency times wavelength, where speed that I'm talking about is speed or velocity is the velocity of light in vacuum, that is 3 times 10 to the power 8. Now since this is constant, see the value of velocity of light in vacuum is constant, it implies that F is inversely proportional to wavelength. So more frequency, less wavelength, less frequency, more wavelength, that is evident here. Higher the frequency, shorter is the wavelength, or lower the frequency, longer are the waves. So we have two variables and a constant. If we have f, we can find lambda as c by f, and if we have lambda, you can find f as c over lambda. As long as you use standard units in meter second or meter per second, that is hertz, you should get the correct answer each time. Let us talk about photons. Photons are quantas of energy. That means they are small packets of energy. Each photon may contain energy that is equal to hf, where h is the Planck's constant whose value is given in the bracket and f is the frequency of radiation. Remember that the idea of a photon comes that the light itself, or the electromagnetic spectrum, everything that we can call as light, it can have a dual nature. That means the light can exist as a wave. That you have studied in the previous chapter. You have studied about diffraction, you have studied about interference. That is a result of the wave nature of the light. Now there are certain other phenomena where light doesn't behave as a wave, it behaves as a particle. So those particles are referred as photons. They have some energy, we have a rule for that energy. Now that rule is very simple. So you have a constant and you have two variables. So whatever is missing, you can use the rule to find it. Is E is missing, E equals to hf, whereas F is missing, E by h. Okay. Now, let us look at unit conversion now. As you can see here, the unit for Planck's constant is joule second. So, joule per hertz, or that is joule second. Another measurement that is usually taken for energy or for even for Planck's constant is electron volt second. So 1 joule second is 6.242 times 10 to the power 18 electron volt second. So you can convert Planck's constant as multiply the joule second value for electron volt conversion by the value of Planck's constant, and we get approximately 4.14 times 10 to the power negative 15 electron volt second. For some question we can use this directly. For some questions, based on the value of h or the energy given, we might have to interconvert. Okay, let's see the problem. If the frequency of a bunch of light waves is 5.4 times 10 to the power 15 hertz, what's the energy of each photon? Estimate h as 4.14 times 10 to the power negative 15 electron volt second. So we have the frequency, we have the constant, so simple, E equals to hf. Multiply the value of h by the frequency value, and we have the answer as 22.356 electron volt. Pretty simple question, can be asked in multiple choice questions. Now, the other way around. If the energy of a photon is 3.4 electron volts, what is its frequency? Estimate the value of h as this. So, E equals to hf, so frequency will be E by h. Now here this answer 3.4 divide by the value of h. And the common mistake students make here is that they either don't use the fraction given in the calculator or they don't put the bracket in the division. So they end up with the answer having the value, the multiple of 10 to the power negative something like 15 or 16 depending on your calculator. If you simply divide 3.4 by 4.14, you will get 0.82. In case you forget about this, you tend to choose answer B. You can also choose answer D because it seems 0.82 times 10 to the power 14. But since this is divided by 10 to the power negative 15, your correct answer would be choice A. So that is how multiple choice questions are created. The answers, they tend to be slight variations from the correct answer by small decimal numbers or based on the mistakes that students tend to make. The energy of photon A is Ea. The energy of photon B is Ev. If Ea is twice Eb, which of the following is correct? Twice Fa is Fb. Fa is twice Fb. Frequencies are equal. Frequency of A is 4 times frequency of B. Or none of the above is correct. Now here, energy, as we know, is directly proportional to the frequency. It means that more energy, more frequency. Here, energy of A is twice the energy of B. So that directly implies that frequency of A will be twice the frequency of B. So your answer will be option B here.